Okay, so what's the cheapest way to make electricity? Sounds simple, right? But believe me, the answer is, well, it's become one of the most important and honestly pretty complex economic stories of our time. So let's get into it.
I mean, on the surface, this feels like a no-brainer, doesn't it? You've got a solar farm with, free fuel from the sun, and then you have a gas plant that's just burning through expensive fuel every single second. But here's the catch. Building that solar farm, that's a huge upfront cost. The gas plant might actually be cheaper to get up and running. So how in the world do you compare these things fairly?
All right, so just looking at the construction cost or the fuel bill alone, it's totally misleading. It doesn't give you the full picture. To really figure this out, economists had to come up with a special kind of price tag. A price tag that takes every single cost you can think of, building it, running it, fueling it, fixing it, over its entire life and boils it all down to one single powerful number. And that's what we're here to talk about. This special price tag is called the Levelized Cost of Electricity, or LCOE for short. Think of it as our secret weapon. It's the tool that lets us cut through all the noise and get to the real, true cost of power.
Okay, I know that definition sounds super academic, right? Average net present cost, what does that even mean? But the idea behind it is actually really simple. Just think about buying a car. The sticker price, that's just where it starts. You've got gas, insurance, oil changes, new tires, the whole shebang. LCOE is basically the total cost of ownership for a power plant. It tells you the price of every single kilowatt hour it'll ever generate once you factor in everything. So let's peek under the hood of this LCOE price tag. What's actually in there? First up, you've got your building costs, or CapEx. That's the big one-time hit to actually construct the thing. Then you've got your day-to-day running costs. That's O&M, for operating and maintenance. Now for fossil fuels, there's a huge extra piece, the actual fuel, which as we know can get really pricey, plus any carbon taxes. And the magic of LCOE is that it takes all of this stuff and spreads it out evenly over the entire life of the power plant. That's how we finally get a true apples-to-apples comparison. All right, so now that we have our universal price tag, our LCOE, it's time for the main event. We're going to put all the major energy sources head-to-head in a 2024 showdown. And we're using brand new data from Germany's Fraunhofer Institute. These guys are the real deal. So let's find out. If you were to build a new power plant today, what's your cheapest option? And boom, here it is. This is the chart from that Fraunhofer study. It lays out the LCOE for all the big players. So you've got the different power plants along the bottom and the cost going up the side. Now you'll see each one has a bar showing a range from the best case scenario cost to the worst. But the one thing you need to remember is super simple. The lower the bar, the cheaper the power. So let's zoom in on the winners, shall we?
Wow. Okay, so the clear winner at the absolute lowest end of the scale is large-scale solar. We're talking a big solar farm in a really sunny spot. Get this, it can produce electricity for a lifetime cost of just 3.1 euro cents per kilowatt hour. That is just incredibly cheap. I mean, think about that. And right on solar's heels is onshore wind. If you build a new wind turbine in a really windy spot, you're looking at a lifetime cost of just 4.3 euro cents per kilowatt hour. So let's be clear, the takeaway here is huge. When it comes to building new power plants, renewables are just setting an unbelievably low bar for everyone else to try and clear.
Okay, so let's really put those numbers into perspective, because this is where it gets kind of crazy. A brand new, super efficient natural gas plant, it's almost 3 times more expensive than our cheapest solar or wind. And a new coal plant? Forget about it. We're talking more than 4 times the cost. The economic picture here couldn't be clearer, could it? So that's the what. We know what's cheapest. But the really interesting question is why? Why is the difference so huge? Well, the answer is baked right into the DNA of how these things are paid for. This right here. This gets to the absolute heart of it. Take a look at the bars for coal and gas. See all that glue and gray? That's your fuel costs and your carbon taxes. They're unpredictable, they change all the time, and you have to pay them forever. Now look left, at solar and wind. Almost the entire cost is that big upfront investment. Once you've paid for it, it's built. The fuel, the sun, the wind is free. And that's the fundamental difference. It's what makes fossil fuels such a gamble and renewables so predictable. And a huge part of that gamble is the price of carbon. It's not a fixed cost. In fact, this study projects that the price to emit a ton of CO2 could more than triple by 2045. For a coal or gas plant,
That's like getting a mortgage where you know for a fact the interest rate is just going to go up and up and up every single year. It's a massive financial liability. So all of this naturally leads us to look at the future. If these are the trends, what's our energy world going to look like in, say, 20 years? This chart really says it all. See the yellow and blue bands for solar and wind down at the bottom? They're just humming along, staying low, maybe even getting a little cheaper. But now look at the other lines for gas and coal. They are just shooting upwards. And what's driving that? It's almost all because of those rising CO2 prices we were just talking about. The two paths are completely diverging. And if we put some actual numbers to that, it gets even more stark. By 2045, solar and wind, still going to be incredibly cheap, maybe even cheaper than they are right now. But a new natural gas plant, its cost could absolutely explode, potentially ending up more than 10 times more expensive than solar or wind. That's a staggering difference. Okay, so all of this data, all these charts, they're all building to one final and honestly pretty stunning conclusion. A conclusion that suggests we have officially passed a major economic tipping point for energy. Just let this sink in for a second. This isn't comparing building a new solar farm to a new gas plant. No, this is saying that just the operating costs, just the fuel and carbon taxes to run an old existing conventional power plant is already more expensive than the entire lifetime cost of building and running a brand new solar or wind farm. Think about that. It's literally become cheaper in some cases to build something new and clean than it is to just keep feeding fuel to the old stuff.
So what does this all mean? It means the financial argument is basically settled. The numbers are pointing in one very clear direction. So the question isn't really if the transition happens anymore, it's how fast. Given this new economic reality, how quickly can we actually build the energy system of the future?